And we're getting close to the starting mark of this presentation. Good afternoon and hi everybody, or even good evening depending on where you are. Welcome to this session at NDC Oslo. People will probably still pop in. The nice thing is that we don't hear any doors go open or like being closed because of course it's all virtual. Last year I attended NDC Oslo in person. It's a really nice venue, to be honest, and I was really looking forward, but unfortunately, like, we're in a different situation. So I would like to welcome you to my office, my home office, where I live in the Netherlands, and where we're going to talk about third-party security risk in .NET Core applications for the next hour. First, of course, it's always a good idea to just briefly introduce yourself. So who am I? With a big picture on the side, my name is Niels Tanis, and I work as a security researcher at Veracode. I got a background in .NET development, and I've always kept a sidetrack on application security. So first years of my career, I mostly focused on doing contract work and developing apps, starting with the bits, let's say .NET bits, the first bits 1011. And then I moved more into the security space, which is like 2014-ish, that I moved to application consultancy, security consultancy, and also some pen testing and ethical hacking. And in 2015, I joined Veracode, where I'm right now part of the research team. And what I'm mostly doing is focusing on our static analysis capabilities for .NET applications. So I'm combining all my background, including development, hacking, into a single role where I work on that. So if you want to talk about Veracode, come see me afterwards or drop a message on Slack. Because today we're not going to talk about vendor things, we're going to talk about third-party risks and the way that we can reduce that risk in our site or our .NET Core applications. What will happen if you create a new app, and if you start out creating a new app with, let's say you open up a console and you say .NET new MVC, .NET new console, or even .NET new WinForms, what will be the first thing that will happen once that's done? Most of the time it will get your dependencies from repositories managers like NuGet, right? It will go out, it will get all its dependencies it needs in order for you to be able to build your product. So from that perspective, a big portion of our application consists of third-party libraries that we pull in and we just use. Because the nice thing about that is, like, if there is an open source project that has a nice framework or component that helps you out in your development, you can reduce development time, right? It becomes less. And even if I put my developer hat on it, it's always like, it feels like you're lazy because you're like getting a lot for not doing much, right? But on the other end, there's the security side of that. And if you pull in those libraries, be aware of, like, what do those projects do for security? Like, how do they deal with issues that are being found? You can probably imagine that it's a different world if you're looking at a project that's being run by 5 people in their spare time because they just enjoy technology, right? As everybody does. Can you expect the same kind of response in relation to security issues as, let's say, a bigger vendor that has even maybe a fully dedicated team that fixes issues all the time, right? There's a really disbalance, and especially when we like rely on that part of that library, or like we pull in that library and we develop on top of it. That's definitely introducing risks, right? And we need to be aware of what we're pulling in and why. So I think that's also a bit of the problem space we're going to cover. From development perspective, there's definitely ways for us to improve that posture, how we deal with third-party libraries in general. And that's exactly the goal of this presentation, what we're going to talk about. So let's first define an agenda for the next 50 minutes. And we're going to start out with identifying some third-party security risks, because there's a whole variant of it. And I want to share some examples with you of what will happen if software gets compromised that we use. Then we're going to move to a subject of the rest of the presentation. So there's a demo app that uses a component that has some issues inside of the component itself. And I want to show you some ways on how we can maybe fix those issues or make sure that those issues are less of a risk. And that's something that we're going to achieve by doing some compartmentalization or isolation of the functionality with some code patterns. Then on the flip side, like after that, the second part of the presentation will focus more on doing reviews of components that we pull in, because I think that's the other pillar that we need to improve on. Like looking at APIs and have some understanding of what's inside, I think that really helps us out doing a better job. And then at the end, there's a conclusion and Q&A, and we will probably open up the audio channel at the end. Feel free to drop a chat question right now in the WebEx chat, or come see me afterwards on Slack. It's all possible. There's a variety of possibilities to communicate, and that's nice, right? So let's first define some problem fields with third-party security risks, and what are those risks, right? As I already said, if you build a .NET Core application, a big portion of it will be built on top of dependencies you pull in. And it's definitely important that the developer will use a library as it has been intended to be used, right? And what I mean by that is, of course, an API of a library. Let's say you've got a data access layer that allows you to do queries on a database, right? And it abstracts away all some of the problems. Then if there is some ways of dynamically creating queries, that's of course a risk area, right? And the developer should, of course, not use that by default. There should be some guidance on that, because if it uses dynamic SQL, then of course you probably are aware of the fact that there might be SQL injection inside that application that will result in more problems. So aside from the fact that the API needs to guide the developer taking the right decisions, the developer also needs to have some more knowledge, in my opinion. The third option is already what I talked about, like what do these projects do for security? How actively are they releasing new things? And is there a possibility for a security researcher to share a problem that he has seen, right? So it's definitely something to consider if you're using a library. The fourth one is, of course, we need to analyze our applications on the third-party libraries that we're using and see if there's maybe versions that we need to update to because of some security patches that are inside, right? That's of course a key thing to do. And one other thing that should definitely not be underestimated is something called transitive dependencies. And what I mean by that is usually when you want to do something with an app and you pull in a top-level package, there's usually a whole transitive tree underneath that. So it doesn't mean that you pull in a single package. No, it means that you maybe pull in several packages that are part of that whole tree, right? So there's a bigger set of that. So these are like different risks and different the different third-party risks. We're gonna see more examples later on. And to throw in some statistics on this, each year we publish something we call the State of Software Security, where we share some of our metrics of the apps that we've analyzed. And if you're interested in those reports, come see me afterwards. But I think the key statistics I want to share with you is that in our 2018 edition, we saw that 85% of the applications that were analyzed for the first time have at least one vulnerable component, meaning that there was one vulnerable or at least one vulnerability inside of a component that was used by the app. In the 2019 edition, we didn't have those statistics, but luckily a month ago, we published an open source edition, which reflected exactly the same statistics. So I was happy to see it because I could use it right now. And there is at least a decrease, what we have seen, and that shows that it's like only 70% of the analyzed applications contain at least one vulnerable component, right? So there's some improvement. Still, I think it's a big portion, and you need to be aware of using the last version of a component, right? I think that's the key of this. Because if we then move on and see what could possibly go wrong, I think the biggest example in history might be the Equifax data breach that happened in September of 2017. Not sure if there's any people from the US in this room, but turned out that there was an Apache struts vulnerability, which was identified with a CVE number, which is like a logical number that they tie to a security problem. And in a window of 2 months, where the server was not updated, they were breached, and 143 million US consumer records were stolen. So quite significant. And what they should have done, of course, is make sure that once the release was done of the fixed version in March, update right away, and this would not have happened, right? So that's one example of a third-party risk and not updating components, which is of course a key essence of the whole thing. Another thing I would like to quickly do a sidestep to is something that we call supply chain attacks. And what I mean with that is that with our software and the way that we develop our software nowadays, it consists of a lot more than just code that we check into a repo, right? Nowadays, we do build pipelines on Azure DevOps or GitHub Actions, right? There's a lot more, even GitLab, you can do a lot of variety of things. And all the steps that we do and all the steps we need to do in order to build our product or release our software can be identified as a supply chain, right? Every step. So the fact that some components are being pulled in, tests are being run, right? Every piece is a step inside of the supply chain. And what we see nowadays is that it's also a target for attackers to add malicious functionality to like hack into a build pipeline. And one good example of that is something that happened with NPM's event stream, a package called event stream on NPM, and that happened in November of 2018. To give you some sense of what happened, it's like this package had a 2 million download count a week, which is quite significant, right? 2 million downloads a week. And that was all due to the fact that it was a transitive dependency of 2,000 other libraries. Because if you look into the functionality of the library itself, it wasn't a lot. And it also was a stale library, is how they call it, which means there was not much active development done on that library to fix problems. Somebody stepped in from the community and started to do some fixes, and it was all like helping out. So then eventually that person got ownership of the project. And what then afterwards happened is that he decided to add some malware inside that package. And that was eventually targeting specific crypto wallet cryptocurrencies to steal that currencies, right? So in this case, there was it's a pretty, if you see how much downloads it counts, that's a lot, right? And if you see the reach that that package has, it's quite significant. But in this case, somebody was joining that team and misusing the trust as an owner to release a package, right? That's one step. If we then look into something that happened 2 weeks ago, which was published by GitHub, by the GitHub security lab team, is related to malware that targeted a specific IDE. And in this case, it's tied to NetBeans and a NetBeans IDE. And what this malware did was it infected the projects that were being built with the NetBeans, and it dropped additional functionality in the output. Meaning that some malware and some other stuff, I don't know the exact details, was being put in, and it reproduced itself. So every piece of software that was built with that IDE got additional functionality inside of it, which was malicious. And of course, if you think about it, what would an attacker try to achieve with that? Usually developers have got access to a lot more resources within an organization, right? So that might be a motivation, because if you think about it logically, I honestly myself, I would not target an IDE, but maybe even a build pipeline, because then you can infect a product, right? An output of that supply chain, and then maybe even reach out to more people, right? So it's, the key thing I want to tell with this is that this is something that's it's happening, and it's targeting a lot of different things. And even looking at libraries that we use and the supply chain that we have, it becomes more complex. And keep in mind that each packet has got its own supply chain also. So a library that's being built and being shared with the developer community, that also is a supply chain. And if that supply chain gets compromised and you use that library, that inherently means that your supply chain is also compromised in the same way. So they're closely tied together. So it's something to be aware of. If we then look at packages and supply chain attacks, hey, maybe we can just sign packages, right? That's a possibility. We can get a code signing certificate and we can sign a package, and then it's all good. It turns out that signing NuGet packages is not as trivial. Also, it's expensive to get a code signing certificate, and there needs to be some steps done. Not a lot of packages do it themselves. That's exactly what Phil Hack writes about in the blog post of 2019. And the alternative would be to do some let's say, trust the owners of a specific package. That would be the alternative, which you can say hey, if something is published by this development group, then I will trust it, right? That's a similar thing. I think the key thing with this supply chain is that it's a much broader problem. It goes much wider, and I can even dedicate a whole session on this supply chain attacks on its own. But keep in mind, let's say if we have a package and we get it from NuGet and it's signed, what could possibly go wrong? And I think one good example I would like to share with you is something that happened to the ASUS live updater software that's being installed on a new machine once you buy that, right? Which is the update software that will reach out to ASUS, see if there's any updates, and then pulls it into the machine. So it's not a development thing like a third-party library that somebody programming against. No, it's updating the machine itself. In 2019, the people from Kaspersky Labs identified something that they called Operation Shadowhammer, which turned out that the ASUS live updated software, its supply chain was compromised. And it ticked all the boxes. And what I mean with that is that the package was properly built according to all standards. It was even signed with the ASUS certificate. And the only way you can see something was wrong with this package before you install it on your machine is look at its internals. And that's exactly what the Kaspersky people did. They identified some malicious activities or like some malicious functionality inside libraries, and they decided to investigate further, right? And a similar problem lies with the way that we pull in libraries, right? If we trust the publisher, or if we look at, let's say this comes from a trusted source, then it's not necessarily true that what's inside is really a valid thing to use. And that's the thing we're definitely going to touch more details on during this presentation. So these are different scenarios, different third-party risks. Right now, let's move to the practical part of this presentation. Let's focus on an app that has some issues. So I created a demo app, which of course is developed badly. It lacks some best practices, let's say like input validation. There's a lot of things it can improve, but there's a component used, a third-party component, and that component itself has some issues. To give you some sense of what the app is doing, it's allowing you to administer some favorite places, and I come up with a demo to say like, hey, I would like to have a list of places that I visited and maybe write down some stuff that I liked about it. Turned out that that is not such an original idea, but it fits the needs for this presentation. Small side note, the photo that you're seeing right here is the nice Koppelpoort in Amersfoort in the Netherlands, and it's a nice spot to visit. So let's move to the app, and let's move to VS Code, and let's dig into some code and then work through what we're faced, like what the problems that we're gonna see today. And let me see, I'm switching my screen to VS Code, and I'm hoping that you're seeing my VS Code right now. And you are seeing my screen, so that's good. I got a bit of a slow response on my second screen over here. Oh, that's cool. So let me do one more thing. Go back. No. That's cool. Maximize this window. Get rid of this. So the first thing we're going to briefly dig into. So this is the app. There's a source code we're going to dig into. I want to do a list package of this project, right? So this is a CLI command that will publish, or that will show us all the top level packages that are used by this application. And what we see over here is that it's a .NET Core 3.1 app, right? That's the basic profile. And then we see it has a component which is called Awesome PDF, which, trust me, isn't as awesome as it is because I created it, but there are some transitive dependencies that have issues inside, which we're going to focus on. And aside from that, it also stores some data, right? So it needs some SQLite Entity Framework core. If we do the same command and then say, let me also get a list of the transitive dependencies, then we will see the list will be a lot longer, right? Aside from the things that we need for our, let's say, the .NET Core 3.1 app, there's also a package added which is called iText7, which is probably used to create the PDFs. There is some Bounty Castle project inside which can be used for crypto, and there's some SSL being pulled in, some native libraries. So there's a lot more behind it, right? So we have that top level thing that I talked about and the whole tree underneath, which consists of this. So let's close this terminal for now. Let's just allow me to give a brief demo of the app and show you the problems that are inside. And show you the security problems that this app has. So it's just a basic MVC app, and it allows you to administer places, right? So it's default template work. I'm no UI designer, so I just stick with what the default gives. And of course, what you see over here, there's a list of places and there's some data you can edit right over here. We can see that there's a name, there's an image, right? That refers to what seems to be a file, and there's a piece of text which we can edit. And if we then press the report button, what will then happen is that it will generate us a report, which is a PDF that contains, assumably, the picture you saw in that file name and the text and some titles. And before I quickly continue, I just want to make one brief sidestep to one place being mentioned in this list, and that's the one at the bottom. And that's a place called Middenmeer. You probably would ask like, hey, Niels, what's Middenmeer? So this is the place where I grew up and spent 20 years of my life. And the next time, if you create something on Azure West Europe, then this is the data center you will end up in. And it's literally next to the village, a small village where I grew up called Middenmeer. And it's quite impressive to ride past it. So if I visit my parents, then I will see it. And it's even an attractive area because aside from Microsoft, Google is also putting something next to it, which is even bigger. So there's a lot of stuff happening over there. But next time, if you're creating something in West Europe, then be aware that that's Middenmeer, right? That's not even Amsterdam, the Netherlands. No, it's Middenmeer. So make sure that you keep that in mind. So let's now focus on the problems that this app has, right? So as I said, we can edit data, and turns out that the PDF that has been generated has some relation between the name that has been given to the place and the file name that it eventually creates as output, right? So yes, no, these are bad practices. There's no input validation, but we're going to focus on the way that the component deals with this data. So we're just going to work with that. So if I then do a // because I know that this is a path, and then say, let's save this file as NDC Oslo, or like, let's see, save this name as this. And if I then generate the report, we see that the report has got some weird name, but I can also show you that inside the web server, there's a PDF created called NDC Oslo. And it turns out that, as I said, the name input is being used by the component to generate a file path. And that's also known as a path reversal or a CWE73 problem. And it allows you to write PDF files outside the root folder of the web application, right? We can even go up more levels, // There's a lot of potential in doing that. The second problem we have is that we see over here, there's an image, and there's an image that's a name, which turns out to be just a file path also that loads images. Let me see, I think it's even one up and not there. Yes, there it is. So there's a folder that contains images that can be loaded, and that will be loaded by the report generation. There is also the possibility to not put in a file name, but to put in a URL instead of the image. And the report that we then generate will go out, will fetch that image from the internet, put it inside of the report, right? And the problem that we see over here from security perspective is something we call a server-side request forgery. So input is being accepted from an external untrusted source like an end user, and then it will be used to do a request on behalf of the web server to some other external source. And in this case, it goes to a web server to fetch that image, right? In this case, this is the Market Square in Amersfoort where all the restaurants are. So it will get it and it will put it in. So there's like, those are the two main problems inside this app that we're going to focus on and that we're going to fix by doing some other changes. So let me quickly go back to VS Code. Let me show you some of the code that's behind, because it's relatively simple, but I just want you to see the way that the reports are being generated, because that's the code that we're going to focus on. So the project itself has a dependency, a package reference that references the awesome PDF component, right? That's the thing that's used. And in this case, it will instantiate a generator that we see over here. It will say, hey, please generate the PDF for me. It will pass on the data, right? That's the title, the image, and the text that's being used. And afterwards, it will then return a file content result that will read the bytes, and it will stream back the PDF to the end user. So this is the functionality of the controller that gets the third-party library, the PDF generator, uses it, and produces the output that comes back. We're going to move back to the slides and recap briefly what we have seen. So, two problems. The path reversal, right? So the dynamic creation of the file path, that's been externally controlled. So that's something that somebody can type in. Let's say this is a social media thing that everybody can like jump into. Then of course that from that perspective and that audience, there will be more users and there will be more risk. And as I already told you, like there are different ways, and you can probably traverse directories and write out files. One constraint it has is that it will always be a PDF that it writes out, right? Because that's the thing that the component will create for us. So we cannot create any other files. And it will also add the .pdf extension to that output file that it creates by default. So keep in mind that file systems and directory names and file paths have constraints on systems, right? Which might result in truncation of file name. So there might be a possibility for us to override or like cut off the extension and then write back another file in some location. So there's a lot of potential. That's what I'm trying to say, and it allows you to override files. And that's problem one. The second problem is the server-side request forgery, which is also known as CWE 918, which will be identified as an information disclosure, but I think it's a lot more powerful than just the information disclosure. Let me explain to you based on a couple of examples. So it's also possible to access files based on this, right? So you can also express yourself like that file / URL handler to some file that you want to open and then maybe see what's inside. You can also connect maybe to say like, hey, I want to connect to HTTP localhost 3306, which implicitly, of course, is the MySQL server port. And if that one is open, then you might get a response back from that, right? So if you put that inside of the image URL, then that will be done by the web server, and it will request data that's on that location. The third URL probably is familiar for the people who run with Azure, right? That's the metadata service that you can access from Azure. And if you put in this URL, then supposedly it should get the metadata that's tied to that Azure VM instance where this is running in, if this application would have been deployed on Azure. Luckily, I think there was some kind of threat model that like saw this, and with Azure, there is a need to also add a custom header, and you cannot do that request without that custom header. So this won't be vulnerable in Azure if you do this. On the other hand, if we then look at other cloud vendors, so the thing that happened with Capital One and its data breach that was in August 2019 of last year, it turned out they had a server-side request forgery issues in one of the apps that they run. They run on AWS, and somebody was then able to get the metadata service from AWS to expose information, and that also contained tokens that allow you to get access keys to S3 buckets. And that was exactly how that server-side request forgery issue was used to then do that data breach. And I believe even that app was running behind a web application firewall, and it was all locked down. But keep in mind that if this web request is done by the web server, you're already in that server, right? And it will be done on that behalf. And that's exactly what happened. So it's quite powerful. In our case, there's not much like, we cannot like grab a file and read its contents, because the PDF component will constrain us to only grabbing images, and it will fail miserably if we load something else aside of an image. But we can definitely use it to probe and to see and use it as a side channel by saying like, hey, if this file is present, then the request will probably be a little bit quicker than if the file is not present, right? And then use it as a so-called side channel. If you're still not convinced about server-side request forgery being an issue, then I would suggest you look for bug bounty stories and also include the acronym of server-side request forgery. You will find a lot of good stories where people explain how they hacked the system, and where usually server-side request forgery is one of the stepping stones that they used in order to get the hack done. So I think that this is also one that has a lot of potential. So moving out and moving to the next part, is there a way for us to do a better job, right? And I would like to focus on the way that the app uses the PDF component to generate the output. Maybe there are ways for us to isolate this functionality and to lock down its capabilities, right? And I would like to focus on doing it in C# in code, and also within the same process. And I also would like to just take the PDF library and use as is. I don't want to have any changes on it, right? Maybe there's a way for us to create a sandbox for that PDF logic within the MVC app, and preferably a sandbox that has limited capabilities. If we then look into the .NET ecosystem in general, then would there be a component that maybe fits our needs? And the answer is yes, there was a component that would fit our needs, which is called System.AppDomain. And if we looked into the definition of it says that it's an isolation boundary for security, reliability, versioning, and unloading of assemblies. And the most trivial thing, it has been around since the first bits of .NET, and in combination with code access security, you can take one app domain and create a second one inside of it, and then allow it to load some untrusted code. That was the examples you saw in the beginning, right? Which is kind of similar, the similar part that I would like to approach with this application. If there are people in the room that are like developing with ASP.NET Core 2.0, they probably are aware with something called trust levels, which was an implementation of code access security on top of an app domain that was on an IIS server. And what that resulted in is that if a single process is run, and that was like the shared hosting time when everybody was on the same web server, and if you then within the application, within the .NET application, request the temporary files, then you'll get the temporary files of everybody. But if you had trust level medium, then that was not allowed, because that was like being locked down. As from 2017, Microsoft stated, don't use this as a security boundary, because it isn't. And it turns out that there is a mutex, a memory, even a user memory that you can just like flip, and that will allow you to turn it off, and you can completely circumvent it. And if you're interested in seeing some code, come reach me afterwards. I can share that with you. One other thing is that System.AppDomain is also not fully supported with .NET Core. And what I mean with that is that there is a knowledge of app domain, but there's only a single instance of an app domain once an application starts, and we cannot create a second app domain inside of it. So that's unfortunate. Luckily, there are some internals that are being moved out of app domain that are being like added to the base class library, and that has got a lot of potential. And that one is called System. That's in System.Runtime.Loader, but it's called Assembly LoadContext. If we look up the definition of that, then that's a scope for loading, resolving, and unloading a set of assemblies. And the demos you see around the assembly LoadContext is that it's usually used to load different versions of a same DLL inside of a single process. I think last year David Fowler showed a demo where he took two assembly LoadContexts and loaded different versions of Newton self.json, and that was the demo he showed, right? So that's something that's possible. Inside the concept that we're going to move on to after this slide, and we're going to move back to VS Code, I'm also going to use a concept called self-contained deployment. And I just want to briefly explain that if you do a publish of a .NET Core app within the CLI, you can also do something called a self-contained deployment, which means that the output of that publish will contain the application and all its dependencies that it needs in order to run. So everything inside that folder will be the assemblies that you need in order to run that application, right? And in conjunction with assembly LoadContext, I think that can be a quite powerful concept to use. So when I initially worked on this, I used the plugins library, which was created by Nate McMaster, who was then working for the ASP.NET team and working on ASP.NET Core. And as from .NET Core 3.0, assembly LoadContext surfaced a bit. There was more things exposed with it, and you can easily implement your own. So that's exactly what I did for the demos after that. So enough said, let's move back to VS Code and let's dig into some code and see if we can fix it. So first, let me switch to another folder. And let me show you what we're gonna do right now. So I've explained a lot. I talked about assembly LoadContext. Just bear with me. I'm gonna talk you through like how the solution works and how eventually we're gonna like hopefully sandbox the functionality of the PDF library. The first thing that we need to do is to make sure that we take out the PDF generation itself and put it in a library, that it's like on its own, that we can put it someplace else, or maybe even run it in a different process if we eventually want to do that. There's one thing we do need, and that's a definition of like how can we talk to that library. And the first thing that I've identified is an interface, right? The interface is just a contract. And if you can recall the controller we saw earlier in this presentation, this method just matches the generation of the PDF, and it's in an interface. If we then look at myPDF library, that's the project that has the reference to awesome PDF, right? So that's the package reference to the PDF generation itself. And if we then look inside that, then we see that there's an implementation of IPDF service, right? So this is a component that matches that interface, and that, if we look at line 15 or line 16, we see that there's that functionality that we saw earlier, right? Instantiate the PDF generator and generate the PDF and return the results back. So what happened here is that this library contains the PDF generation, and we've isolated it in something separate. I did put in two code base calls over here, and I put them into strings, and that's something for the demo purpose you will see later on, because I want to show you where these types reside and from which folder it's loaded, because that's the essence of the thing that we're doing. So now let's focus on how we're then going to use this component from our MVC app to have more control over what's happening, right? And still, we don't want to change the PDF library. We just want to use it as is. First, let's quickly see that I'm not faking, so I removed the reference to awesome PDF, right? It's not here anymore. It's just doing the data entry, and there's a project reference that points out to the interface library, because that's the contract we use in order to talk to that component. If we then move to, let's go to the load context right now. So I've implemented my own assembly load context that does some things, and there's a lot of stuff happening, and I will just explain to you how the decision making goes within this thing. And if you're interested in seeing the code, then in my last slide I will have a link to a repo which is already there that contains all this code, and you can just go through it yourself. But in this case, what we're doing over here is that we create an assembly load context, our own, and we define a path, and that's the path that will have the self-contained deployment of our myPDF library, right? So that's in essence what we're going to do. I'm going to deploy that thing later on, and you will see there's a self-contained deployment published done to a folder that's a subfolder of this app. And the second argument is the shared types that I talked about. So if you have two assembly load contexts, and if you then load type A in a context, the first context, and type A in the second context, and if you would then compare those types, then they will not match. So what we do need to do is that we need to have some shared type, and that's the interface in order to talk to the PDF generation that's in the second load context. That's what we're doing. So we need to keep track of those. So that's exactly what happens in that second part of that constructor. Then the load function takes care of the logic. And what it does is like, hey, are you interested in maybe a shared library? Then you will return null. And what that means is that this load context will tell the default one, which is like the root of the app, to just take care of it, right? And in case of the interface, we want that. The second thing is that we take the assembly resolver, which is also part of the framework, the assembly dependency resolver. That's part of the .NET Core framework that will then do the resolving based on the assembly name, and it will give you a path back. And that's a path we're going to use to load that assembly. And if it's not found, if it's not part of that folder that we have that self-contained deployment of that myPDF component inside, then we're going to say like, hey, we're not able to load it. We want to stop. Underneath, there is a function that also does the same for unmanaged libraries, and it is a bit of a trick because I'm not doing a return null, but I'm returning an in pointer 0, because a self-contained deployment should have all dependencies. And even if we're like doing cross-platform, right, for Mac OS X, there might be different dependencies needed than if you would deploy this app on Linux, right? There are some differences in it. There also are some exceptions to the self-contained deployment that are still libraries that are coming from the system itself and are not part of the self-contained deployment. So there's no way that we can control it. So for that reason, I'm still pushing back on some unmanaged loading. But the functionality that we're going to patch is solely focused on managed code. So we're fine with that, right? So this is the isolated context. And now we need to make sure that the controller has got the piece available, right? So if we quickly take a peek into the controller, and if we then move to the report method, which is a bit below here. Oh, that's file. It's a bit up. There it is. What we see over here is that we have an IPDF service. If we scroll up to the constructor, we see that that's the interface, right? is the interface that gets injected by ASP.NET Core DI. Over here, we just replace that with the call to that interface. That's all that has been changed for this controller, right? So it's not talking directly to an instance, it's talking to the interface. And of course, we need to do something about having that interface available in our services DI, and that is this part of the code base. Once again, I'm confident that this is not the most efficient way, but it works. But let me just briefly walk you through what's happening here. So we create an isolated load context, as you just saw, and we restrict it to that directory where my PDF libraries publish is being done inside of, right? Then we're going to say, okay, load that, load those assemblies that are there, and then ask that load context to give back all its types that are available. And for each of the types that I find, I will say like, hey, does this match IPDF service? And if that is the case, then I'm going to create an instance and add it as a singleton to our services DI for this ASP.NET Core application, right? So that isolated context will create my PDF service that matches this interface, right? And that will then be added and then can be used. So that's in essence what we have done. So we have taken out that functionality, put it inside of a library that we can control more. And of course, as I said, I need to make sure that it's published. That's what I'm going to do right now. And I don't want to be like doing the demo god. So there's a build script for that. And it's inside of my PDF library folder. So there's a build deploy. And to show you that it's not anything fancy, just quickly opening it up. So what it does a publish, right, of this version, and it does the output, and it does a self-contained deployment of this library. And if we then look into, and what I also do is I copy it to the Bing debug location of this project, right? So I can use it because that's the way it expects it to be in that path. So let's now start out the project. So let me quickly just make sure that I got some breakpoints set so we can dig into and see what's happening. That one is in. Make sure that it's set. So let's now start the app again. And let's see where the types are loaded, right? Because that's the thing I'm mostly interested in seeing. So we got the same app again. And we can do the places, right? We can do the edit. And of course, the thing that we're interested in seeing is the reporting. We get into this function. And if we then step into, we end up in the PDF generation library that we just implemented. And I would like to step over these two invocations. And what we then see is that we have loaded my PDF project from a subfolder inside of our bin debug folder of this MVC project, right? So that's exactly what we want. And we also see that the HTTP client, and that's the thing we're going to focus on after this, is also being loaded from that same subfolder, right? So my PDF library, that's system.net.http.dll. If you request that type HTTP client from this load context, then it will come from that thing, right? So then we can just continue, and you will see that the PDF will just be generated. You get output. If I go back to the browser, we will see like, hey, this works, right? So right now, what we have done is we've taken out the PDF generation. We put it inside that separate load context that has limitation on where it gets its assemblies. So maybe we can just be stubborn and maybe just remove HTTP client from this whole equation. Because, right, there are two ways. We can generate a report based on a file name, and we can put in the URL as we saw earlier. So let's just quickly put in that URL for the demo's purposes. Hold on for a second. So save. Let me quickly just report to show you that this is also still working. Of course, we're going to mingle with some types. So yes, right? Market square, looking good. Okay, cool. So as I said, let's now be stubborn. Let's just do the following. Maximize the terminal a bit. And we need to go to favorite places, bin debug folder. As I said, this is the my PDF library, right? So this is the debug output of the app itself. Was right there, and you see like this is like the normal thing you will get with an MVC app. And if we then look into the my PDF library subfolder, then we will find all the other libraries, right? And it's iText, it's awesome PDF, it's all there. And as I said, why not be stubborn and delete everything related to System.net.http. And let us now restart the app and see what happens. Just waiting for a bit to rebuild and the debugger to be attached. So if we now generate a report, still get the breakpoints. Let me turn those off for now and let us continue. We will get an exception, right? Because in this case, we saw that there was a URL that will normally grab that picture from that external location and then get it in, right? And that's, so this looks like this has succeeded or like we fixed something. But let's check it and let's go back. What if we right now do a report with a file that's local to the system? And there, for some reason, there's still a code path that relies on HTTP client to be there. So this is not the solution. So what if we replace this HTTP client with a stub? And that's exactly what we're going to do right now. So let me quickly show you a file, a single file. This is inside a different project. And if you see the namespaces matches HTTP client, and it has a method called getStreamAsync, right? That accepts a URI. And what we're going to do in that body is throw a not supported exception and say like, hey, you're allowed to do this. Let me quickly deploy this. And once again, you already have guessed it, I got a script to do that. And I need to make sure that I'm in the right folder. There is System.net.http. There's a build deploy script, which will copy this HTTP client to that bin debug folder of favorite places, right? Of the app that we're looking at with this VS Code instance. So let's close this. Let's close this one also. Let's do, let's give one more shot. Also need to keep an eye on the time and move on after this to the next stage. So what if we now want to do based on a file? Looking good, right? This is the nice city of Boston. And if we then go back and then try it with the one that has a URL, we nicely get our exception. Like, hey, you're not allowed to use this. And to show you that I'm not tricking is that within the controller, and you probably have seen it in the beginning when I scrolled back, there's another method called file. And the file action will get a file, which is the same photo you saw earlier. So let us quickly do a breakpoint over there. Let me go back to the solution, and then let's request that action to show you that we're still able to grab files, right? So in this case, this is the main load context. And what we see over here is that the code base of HTTP client is our shared folder, right? So we can still use that. And this is the main assembly load context. So we can still grab that image as we see over here, and that's still intact. So we have separated that functionality. So this is a success. I'm going to quickly recap this. So first, this is a concept, right? And I can definitely see issues like this is not something you can fit into a developer workflow. And I'm definitely considering like, hey, what are the things that I can change in order to make it more accessible? But I think this definitely has a lot of potential by having that separate load context and having control over the types that are being loaded, because you're just going to strip out the types that you don't want the library to use without changing the library itself, right? So you're just going to take the BCL calls that it does and do something with it, as I've shown before. One thing that is similar to this would be the IL linker that was released with .NET Core 3.0, which does some kind of tree shaking. So it is introduced to do some size reduction of your app if you're deploying it. I can also imagine that you might want to be more aggressive and strip out types. I'm going to talk about API reviews, and there's a tool that I'm working on right now, and I'm developing a version that also can do patches in the same way you saw that I did it with that stub I just put in. So keep an eye out on that. But with that said, I just want to briefly touch the way that we develop software right now, right? This is a monolith application you saw earlier, and it has all the functionality glued into one single solution. If you would have created this app in an enterprise environment, you probably would have created a separate version of let's say a microservice that does the PDF generation, or maybe even a function or a serverless thing, cloud native thing, that does that thing for you, right? Which is like more isolated, fits the purpose. It only is responsible for doing that. If it maybe is running on a Docker, you can lock down the image. You can say the Docker image is not allowed to do egress internet traffic. It cannot go outside, right? There's a lot more to lock down. I think the solutions that we create should have multiple layers of defense. So yes, the way that we write our software has changed, and it's become smaller, and we can reduce the risks already. But it's always good to have multiple layers of defense for these types of issues. So this is the part where we have fixed it. And now I want to quickly move to more like reviewing third-party libraries in an application. And I want to be like reviewing the intent and some of the internals and have some sense of what's happening, right? So picture that as the ASUS example I gave earlier, you pull in a library that is totally like, it looks legit, but are you completely confident of what's inside? And that's the thing I want to focus on. I also want to emphasize that, of course, there's a difference between components and frameworks. Frameworks usually have much tighter integration into your app. Let's say like MVC is highly like connected to the code that I'm writing with all the controllers, right? So it will be harder to isolate that. And the component we saw earlier is the PDF thing, and it's on its own. And that allows us to pull it out and isolate it, right? We're going to do some reversing. And I just want to make sure that if you do reversing of .NET assemblies, always comply with the license of the component, because it might not be allowed to do that. That's my disclaimer, so don't take it from me, but you're not allowed to do that. I'm going to skip this one for now, and I want to move to the review of the component in order to have some time left for questions. So let me quickly go back. Did I just like close my slides? No. Okay. Let me open up a terminal. So what I created is a tool that's called Fennec. And what it does, it uses a component called mono.csil. And mono.csil can be used to look into .NET assemblies and to look into its IO, right, and dump it. And I think also for the sake of time, I cannot like do any quick view of the code itself and what it does. It's relatively simple. I'm going to go to the bin debug location of the app that we have just like looked into, right? And we're going to go to the myPDF library. So what it does, it just looks into an assembly and it just dumps out every API call that is done based on a specific format. And let me just generate it for you and then explain to you like why I think this might be a valuable thing to do. So I'm going to do the call. I'm going to say this one is just on NuGet. You can get it, and it's a CLI tool that will install itself. I want to do output for awesome PDF, and I also want to include iText DLLs because that's the thing that most of the problems reside in the way that it's being used. If it's then generated, let me do a code reuse of this, right? So what it does, it creates plain text files, and there's a lot of info, but trust me, let me just talk you through and show you what is it, right? So it will just go over the types, the method, and the method bodies and show all invocations. So there is no logic checks of, let's say, if this code is reachable or not. It will solely look at API calls and dump that out. And because of the pattern that I'm using, you can easily create a block and say like, hey, the generate PDF method does this. And you see that it instantiates a PDF document, and it will then do some image adding, right? So that's the image factory create. And I know for certain that there might be a problem in that. And I've also generated the same type of files for the iText thing, which is being used by the awesome PDF. And you can just connect the dots. You can just go through and tie the calls to each other. And if I then look for get stream async, let me just quickly grab that one for you in the second one. We will get into a URL util OpenStream method, and that's this one, right? This is this body. And this is exactly the code path we have just fixed during our demo, right? Which we have altered the thing for. So it first checks if it's a local file or local path, then it will open a file stream. If not, it will create that HTTP client and it will get that stream async, right? And we have altered it that it can still load the local paths, like the local files, which inherently still keeps the C-serve problems related to files, but it cannot go externally anymore. And okay, probably like this is the way that you can easily skim. You can search for specific things like binary formatter should like, if a binary formatter shows up at some point inside a DLL, then you should always investigate like what's the reason, because that's causing a lot of issues already, right? And it gives you more sense. And let's say if you do this for each DLL that you output before you release, you can do a diff between this version and previous one and identify things that might be smelly and identify that additional thing that has been added, which you do not expect it to be, right? And that's all about intent, knowing what's inside the library. That's the goal of this tool. Let me quickly go back to my slides, just to wrap it up. Got 5 minutes left, and I do want to keep some open, right? So as I said, the review, it's a pretty minimal implementation. It relies on ITEX#. The path problem can be fixed, right? Because we only focused on the C-serve, but the path problem can be fixed by doing a separate process or doing a micropatch. So can you imagine that you also, let's say, check the path before the file is being written in the same way that we've replaced HTTP client, right? There are some possibilities in that. As we've seen, like the HTTP client, and we've patched it for that PDF component only, I think, which is quite powerful. The tool is available on NuGet. There's a site and it allows you to diff, right, and skim, and there is an alphabetical ordering inside the types that are being loaded. So you should have, each file will have the same like sequence, so you can easily diff on that. And as I said, I'm working on a newer version that also does micro-patching and does a bit more, and also allows you to maybe connect the dots between the different calls, right? That's the next thing. Work in progress. Time is always the issue. You can probably relate to that. If you're interested in a similar solution, then Microsoft released something called the Application Inspector, and it was done in last January. And let me quickly just show you the screenshot of this app. What it does, it takes a code base, right? So it's not doing anything with compile, but it can just like dig with, I think it can do a lot of different programming languages, and it will give you an overview of the features that are being used, right? So, and then you can decide for yourself, like, hey, do I expect this library to have the need for doing sensitive data, right? You can have a better sense of what's inside that library and take better decisions, and maybe focus on reviewing that component. That helps out both developers and, of course, security people within the organization. So with 3 minutes left, let's squeeze through the conclusion and then open up for questions if there are any. So I would definitely encourage you to at least start reviewing components as I've shown, right? Make sure that you have some idea of intent of libraries and what they're doing. Consider compartmentalization of logic in different ways, like doing different architectures, or maybe the way that I'm working it, but right, it's still work in progress, but I definitely think it has potential. And this does not remove the need for, of course, any other best practices like input validation, defensive coding, right? And making sure that security is part of your development lifecycle as a whole. That stays as important as always. But as I said, you want to have a layered approach on fixing this problem. And this is a smart bit that we might be able to do from development perspective. So with that said, I would like to thank you for your time. And with 2 minutes left, I would like to open up for questions. If you have questions, you are free to ask them in audio. I think you're able to unmute yourself. Otherwise, drop them in the chat. And then let's see if we can ask it.